What's up, boys and girls? Welcome back for a quick little 5-minute lesson on dependent and independent probability. Okay? Two events are independent if one event happening has no effect on the likelihood of the other event happening. Two events are independent. Let me go ahead and just fix that. Timeout. Gonna just fix this on the fly because we got it. Two events. We're back. Two events are dependent if one event happening changes the likelihood of the other. So let's see. If I select someone from this class to go to the Reds game with me tomorrow, okay, and then I decide, hey, I'm going to pick another person, well, that second event would be dependent on the first one. Because you're more likely to get picked the second time because there's going to be fewer people in the pool. Does that make sense? So as soon as the probability changes, the events are dependent. Another way of thinking it is like, what's the probability that I randomly select an odd number if I toss a tail? Those are independent. The tail has no effect on whether or not I would pick an odd number. Okay? Let's look at some examples. In theory, also in probability, almost everything can be argued. Because I think the first one, shooting free throws, one shot doesn't change the next. Does anybody disagree with that? Yeah, Isaac, come on, talk with me about heat checks.
You'll get tired eventually. If you
Okay, there's fatigue, so eventually your percentage is going to go down if you shoot 1 billion shots. So I like that. What about the mental aspect of sports, Isaac? You're a wonderful athlete.
There's pressure.
Yeah, okay. So like pressure on a shot could, if you're Isaac, make you more likely to make it because you got ice water in your veins. But if you're somebody else, it might make you more likely to what? To miss it. And then there's also just this general sense of confidence that comes with sports. It's like as you do well, you act with more confidence, and as you act with confidence, you relax and you're more successful. So I don't necessarily agree with this, but this is what's weird about probability is that there's always things that you have to read closely, and there's often disagreements. Flipping coins, certainly independent. I don't think you can get on a heater with flipping coins. Rolling dice, independent. Picking players for a lineup is dependent. This is the example we use with the Reds game. Once someone is chosen, they can no longer be chosen again. Drawing cards without replacement, taking marbles out of a bag. Okay, now this thing gets confused with the other. Two events are mutually exclusive if there's no way that they can both happen. So it's like, what's the likelihood that I toss a tail and a head? 0, can't happen. They're mutually exclusive. Can a person draw a card and have it be a diamond and be a black card? They cannot because they're mutually exclusive. However, that does mean they're dependent. Okay? All right, here we go. Let's do a couple. Do you guys know what a number cube is? It's a die, one dice. How many numbers are on a die? 6. You'll need to know some of these things for this section. But if you have any questions about how many cards there are, how many clubs there are, how many face cards there are, you just ask me. That is bad math. If I ask you a question that you don't have contextual understanding about, that is, it can be considered like racist. It can be considered biased. And there's so much bias on tests. Think about like a young person who doesn't speak English, who tries to take a math test, but they're all word problems. Let alone if the word problem's like, what's the likelihood that you get a face card? They don't understand the question. So if you're ever confused about the context of a question, just ask me. I'll clarify for you. Okay? All right. Let's just write out our numbers on the die. 1, 2, 3, 4, 5, 6. And then for this one, let's square the ones that work. So Let's square it if it's even or a 3. Ready? That is even. That is a 3. That's even. That's even. So our likelihood is 4, 6. We got to go with 0.67 on that. Okay? Or 4, 6. Whichever one you prefer. Let's do it again. 1, 2, 3, 4, 5, 6. What's the probability that a number is less than 2 or even? That one's less than 2. That one's even. That one's even. That one's even. That's 4, 6, which simplifies to 2/3. What's 2/3 in the calculator? Obviously. Oh, it's 0.67. Okay. You see the theme. Okay? 6, 7. Okay. What's the probability that it's prime? Uh-oh, you guys know what a prime number is? Anybody know what a prime number is? Come on. 1 is an example of a prime number, but that's not the definition of a prime number. It can only be divided by 1 and itself. So this is prime. This is prime. 2 is the only what type of prime number? The only even prime number. 3 is prime. 4 isn't prime, but it's 4. 5 is prime. 6 is not prime. It's perfect. Do you know about perfect numbers? Do you know about them, Andrew? It's a number whose factors, not including itself, add up to itself. So what are the factors of 6? 1, 2, 3, and 6. Cross out the 6. What's 1 plus 2 plus 3? 6. You want to know how many perfect numbers there are? 51 perfect numbers. Oh, I got to show you this. I think I'm going to show it to this. The most recent perfect number was found in 2024. The person was awarded. If you guys can find a perfect number today, if you give it to me without telling anybody, I'll give you $200,000.
How much did you get?
I'll get $250,000. So I still claim 50. That's a fair trade.
Where are
Okay.
you getting the money from?
From here, let's look it up. Although I'll probably get in trouble on this video. So here, boom.